brand new way of graphing polar coordinates. Most of the time we go over 3, up 2, right? And so this coordinate is called 3, 2. And that gets you from the origin to this place, 3, 2. Right? You get yourself a little triangle, right triangle actually, and all is well. What's different is that with a polar graph, think of the center of the universe here, and you're going outward, circles 1, 2, and 3. So instead of going over 3, it's out 3. Think of yourself being in a submarine in the middle of the ocean and you want to pinpoint a shark. Okay? Well, where you're at, maybe the shark's over here. Well, we know that shark is about 50 feet away, and it's at an angle. Well, this is going to be 0. This is going to be 90 degrees. You can see 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. So this would be my pi. Yeah, this would be. Yeah, this would be your pi over 3, and this would be your pi over 4, and this would be your pi over. This is pi over 6, pi over 3. And so what you can do is you could pinpoint this spot right here by saying, oh, I'm going out 1, 2, 3, 4, 5 circles, and I'm going at an angle from 0 horizontal going up pi over 6. What would this point be? Just shout it out. From the center, we're going out what? 1, 3, yep. And what angle is this with 0? If this is pi over 6, pi over 4, pi over 3? And you got it. Pi over 3 is a little hard to read that. But anyway, that's how we do it. Now, it gets a little bit more complicated, but it's simply the number of circles going out and the angle. And the formula is r comma theta. The number of circles going out, number circles out, and the angle with the 0. All right? Now, that's the easy part. The hard part is you can label these points different ways. You can label them 4 different ways. And we'll talk about that right now. So if you, let's say you had a point, and we're going to look at this point out here, 4 pi over 6. So we go out 1, 2, 3, 4. There's my 4. And then this angle is 5 pi over 6. So what I like to do the angle first. Sweep out 5 pi over 6, and then go out 1, 2, 3, 4. You can do it any way you want, but that's a way to do it. Okay? You could also, if you want to think of it this way, what angle is this if we go in a negative direction? This is negative pi. What will that be? Negative 6 pi over 6. What will it be in a negative direction? Negative 7 pi over 6. You could also call this 4 negative 7 pi over 6. Notice that 5 pi over 6, you're subtracting 2 pi, 12 pi over 6. What's 5 minus 12? Negative 7. So these are 2 ways of describing the same point. Did I lose you? Let's try one. Okay. Let's say I have this point right here, and I want you to tell me this is, let's call this pi, 3 pi over 2. Tell me what that point is 2 different ways. First of all, how far out is it? 2. Okay, so both of these are going to be 2. If we're going to go this way, this is right in the smack dab middle here. How many pi over 4s is that? to get to here? 5 of them. Yeah. Turn to your neighbor. Tell them what the negative one is going to be. It's going to be negative something pi over 4. Five pi over 4, subtract 2 pi. How many pi over 4 is that? 8, right? So what's 5 pi over 4 minus 8 pi over 4? 3. And doesn't this look like 1 pi over 4, 2 pi over 4, 3 pi over 4? Looks like it, doesn't it? Are you good with that? Do you need to do one more for practice? You got it? Okay. Now, the next thing we're going to do is what we call a negative radius. Now, that doesn't make any sense at all. A negative radius doesn't make any sense. But whenever you see negative r, what you're saying is you're saying across the origin from your point. Okay? So if this is, see, what are they looking at? 3.5 pi over 4. So what I like to do is go up pi over 4, like this, and then we're going to go, instead of out 1, 2, 3 and a half, the negative means you go 1, 2, 3 and a half, and you cross the origin, and you end up, 2 and a half. You end up here at negative 3.5 pi over 4. I know, it's kind of weird, isn't it? Let's try it one more time. Let's try an easy one. Let's find 2 pi over 3. So we're going to go out 1, 2, and pi over 3 is about here. So this point here is going to be 2 pi over 3. Now, we're going to find a different point, negative 2 pi over 3. So where's that going to go? Where are you going to find it? Go straight through the origin, and you go out 2. This is going to be negative 2 pi over 3. Let's try a different, yeah?
You don't have to change the angle at all?
No. This point here that we're describing, this point is, we would find it here, but then it would go negative 2 pi over 3 is this one here. So these are different points. I'm not trying to confuse you, but we'll be able to name a point the same way, and that's coming up. Okay, so let's go to right here. Let's take these examples. For each point in the coordinates below, give 2 additional ways of describing the same point. Okay? And they're saying r greater than 0, r less than 0. We'll get to that, but we're just going to do a bunch of these. Okay? 2 to 40. All right? So see if you can find it, and see if you can come up with 2 different ways of writing that. Give it a try. Excellent. So plus 7 pi over 4. And then this one, you don't want to add, you want to subtract 8 pi. So this one's going to be 3 pi over 4 minus 8 pi, which will be negative how many pi over 4? 5. Yep. How many got both of those? We're getting there. We're getting closer. Okay. You can read about this, little details. We're going to get to polar rectangular tomorrow. Here's what you're going to do. You're going to take values. I would draw a circle first, and then find out where 2 pi over 3 is, and then find all of the 4 coordinates for that. You're going to do that for 2, 2, negative 2, and negative 2. This one is pi over 3, so we gave you one of them. You just have to find those others. You're going to do that for these 2, and these 2, and those 2. This one, try these. See if you can figure these out. That should be it. Okay, just go ahead and try that first one. And that's it for today.